Hey learners, today we are going to discuss logical operator biconditional in logic part 6. But before anything else, do not forget to like, share, subscribe, and hit the notification bell so that you will be notified for my upcoming videos. Thank you. Logical operators biconditional in logic part 6. If P and Q are propositions, the compound propositions P if and only if Q is called a biconditional proposition, and it is denoted by P if and only if Q. Alternative ways to state biconditional statement: P if and only if Q is P is necessary and sufficient condition for Q, or P if Q. The table shows that biconditional statement will only be true if and only if both propositions are both true and both false, otherwise false. Example number 1. Write the given statement into logical symbol and give its truth value. The statement is 1 is greater than 5 if and only if 2 is less than 8. Then we are going to let P be a proposition defined by the statement 1 is greater than 5, and let proposition Q be defined by the statement 2 is less than 8. So when we're going to translate now the sentence into symbols, we have 1 is greater than 5 will be replaced by proposition P, and the word if and only if will be replaced by biconditional symbol, and the statement 2 less than 8 will be replaced by proposition Q. Then we can say the logical symbol of the given statement is P if and only if Q. But how about the truth value of the statement? So what are we going to do is we have to identify what is the truth value of the proposition P and what is the truth value of the proposition Q. Then we can say the proposition P 1 is greater than 5 is false, and proposition Q 2 less than 8 is true. By plugging in, the statement becomes false if and only if true. So using the biconditional statement truth table, so when the proposition P is false and the proposition Q is true, the biconditional statement of P and Q is false. Then we can conclude that the statement 1 is greater than 5 if and only if 2 is less than 8 is a false statement. Example number 2. Write the compound statement into logical symbols and find the truth value of the statement. Circle is not a polygon and negative 1 is less than or equal to 6 if and only if 6 is not equal to 10. We are going to let P be a proposition defined circle is a polygon, and proposition Q defined by a statement negative 1 is less than or equal to 6, and proposition R be defined by the statement 6 equal to 10. So let us now translate the statement. Circle is not a polygon will be replaced by negation P, and the word end will be replaced by the symbol caret. Negative 1 is less than 6 will be replaced by proposition Q, and if and only if will be replaced by biconditional symbol, and the statement 6 is not equal to 10 will be replaced by negation R. Therefore, the logical symbol of the given statement is the quantity of negation P and Q if and only if negation R. And now let us evaluate the truth value of the statement circle is not a polygon and -1 is less than or equal to 6 if and only if 6 is not equal to 10. So let us identify the truth value of the proposition P. Circle is a polygon, which is false. Proposition Q, -1 is less than or equal to 6, which is true. And proposition R, 6 is equal to 10, is false. This is our given statement, and we have to substitute the truth values for P, Q, and R to our statement. So as we are going to update our statement, it becomes the quantity of negation false and true if and only if negation false. As what you can see, we have to negate false. So using the negation truth table, the negation of false is true. So as we are going to update our statement now, it becomes the quantity of true and true if and only if true. So as we are going to evaluate now the conjunction of both true based on the conjunction statement truth table, so when P and Q are both true, the conjunction of P and Q is true. So as we are going to update our statement, it becomes true if and only if true. Then, as we are going to evaluate now true if and only if true using biconditional statement truth table, it shows that when P and Q are both true, the conditional statement of P and Q is true. Then we can say the statement circle is not a polygon and -1 less than or equal to 6 if and only if 6 is not equal to 10 is a true statement. Example number 3. Evaluate the truth value of the compound proposition. Negation of the quantity P implies the quantity Q and R if and only if the quantity of negation R or S. For P is true, Q is false, R is false, and S is true. This is our given statement. So what we need to do, we have to substitute the truth value of P, Q, R, and S respectively to our given statement. So as we are going to update our given statement, it becomes the negation of the quantity true implies the quantity of false and false if and only if the negation of false or true. As what you can see, there is a propositions that we need to negate inside the parenthesis, and that is now a false. So as we are going to negate now false, it becomes true based on our negation truth value. So as we are going to update our statement, the negation of the quantity true implies the quantity of false and false if and only if the quantity true or true. Let us evaluate the conjunction of false and false and the disjunction of true and true. We have to work on first with the conjunction of false and false. It is because that is the inner group of the first group in the statement, and the second group will be evaluated also using the disjunction statement truth table. So we can say, as defined by the truth tables of the conjunction and disjunction, when the P and Q are both false, using the conjunction, the statement P and Q is false. But using the disjunction statement, when P and Q are both true, then we can say the disjunction of P and Q is true. So as we are going to update our statement, it becomes the negation of true implies false if and only if true. The true implies false is being group. It means that we have to work on with this one, or we have to evaluate this one. So using the conditional statement truth table, when the proposition P is true and the proposition Q is false, or simply means when the hypothesis is true and the conclusion is false, then we can say the conditional statement is false. So as we are going to update our statement, it becomes the negation false if and only if true. Then as what you can see also, before we are going to proceed to our biconditional operator, we have to negate first the false. So we have the negation of false using the negation truth table that is now true. As we are going to update our statement, it becomes true if and only if true. Then we can say, using the biconditional statement truth table, when P is true and Q is true, the biconditional statement of P and Q is true. Then we can say, the negation of the quantity P implies the quantity of Q and R if and only if the quantity negation R or S is a true statement. And that ends our video discussion at this moment. Thank you for watching. But before you will end this video, please do assess your learnings by answering the self-test activity. Thank you.